Imagine floating in space, looking down at Earth, experiencing weightlessness, but suddenly your muscles start to weaken, your bones lose density, and your vision becomes blurry. Space travel is an incredible human achievement, but have you ever wondered how it really affects the human body? The truth is, living in space is far from easy. Welcome to Kainat Rana Worldview, where we uncover fascinating mysteries and real-world science. In today's episode, we're exploring the shocking effects of spaceflight on the human body and how astronauts survive the extreme conditions of space. Stay till the end to find out what happens if a human is exposed to the vacuum of space without a spacesuit. Section 1, the Ridge Factor, NASA's biggest challenges. NASA categorizes spaceflight risks under the acronym RIDGE: radiation, isolation and confinement, distance from Earth, G-gravity fields, E-enclosed environments. Each of these factors creates serious challenges for astronauts, whether they are spending months aboard the International Space Station, ISS, or preparing for a mission to Mars. But how do these factors affect the human body? Let's break it down. Section 2, microgravity and its impact on the body. Unlike Earth, space has microgravity, which means there's no force pulling your body downward. This might sound fun, but the consequences can be dangerous. 1. Muscle and bone loss. Without gravity, muscles don't need to work as hard, leading to muscle atrophy, meaning they shrink and weaken. Astronauts can lose up to 20% of their muscle mass in just 11 days. Bones suffer too. In space, astronauts experience bone density loss, osteopenia, similar to osteoporosis. They lose about 1.5% of bone mass per month, which increases the risk of fractures and kidney stones. Hat 2, fluid redistribution and moon phase. On Earth, gravity keeps bodily fluids in place. In space, fluids shift upward, causing puffiness in the face, nasal congestion, and even changes in taste and smell. This is why astronauts appear to have swollen moon faces in space. 3. Vision impairment and brain changes. Recent studies show that space travel changes the structure of the brain. MRI scans reveal that astronauts' brains shift upwards inside the skull, causing pressure on the optic nerve, leading to blurry vision. Scientists are still studying whether these changes are permanent. Section 3, radiation exposure, a silent killer. One of the most dangerous effects of spaceflight is radiation exposure. Unlike Earth, space has no protective atmosphere to shield astronauts from deadly cosmic rays. Long-term exposure can lead to increased risk of cancer, damage to the nervous system, faster aging, and DNA mutations. Scientists are working on protective suits and spacecraft shielding to reduce radiation exposure for future missions to Mars and beyond. Section 4, launch and re-entry, extreme G-forces. The human body isn't built to handle extreme gravitational forces. During launch and re-entry, astronauts experience 3 to 6 times Earth's gravity, 3G 6 Grang. If unprepared, they can black out due to lack of blood flow to the brain. To survive, astronauts train rigorously and wear G-suits, which squeeze their bodies to maintain circulation. Spacecraft are also designed to limit G-forces as much as possible. Section 5, surviving in the vacuum of space. What if astronauts lose their suit? Here's a shocking fact. If a human is exposed to space without a spacesuit, they won't instantly freeze or explode. Instead, within 10 seconds, they lose consciousness due to lack of oxygen. In 15 seconds, swelling begins due to gas expansion in the body. After 90 seconds, death is almost certain unless they're rescued immediately. A real-life incident happened in 1966 when NASA engineer Jim LeBlanc accidentally decompressed in a vacuum chamber test. He blacked out in 14 seconds, but survived because rescuers acted fast. Section 6, how astronauts fight these effects. To counteract spaceflight's harmful effects, astronauts follow strict routines. 2 hours of daily exercise, using resistive machines to maintain muscle and bone strength. Specialized diets with high calcium and high protein meals. Sleeping in adjusted light cycles to manage circadian rhythms. Protective shielding and monitoring for radiation exposure. NASA is also researching artificial gravity, which could revolutionize long-term space travel. Conclusion: the future of space exploration. As humanity prepares for long-term missions to the Moon, Mars, and beyond, understanding the human body's adaptation to space is more critical than ever. Scientists are working on advanced life support systems, protective gear, and even bioengineering solutions to ensure astronauts can survive longer missions. What do you think? Would you take the risk of traveling to space if given the chance? Let us know in the comments below. If you enjoyed this video, don't forget to like, share, and subscribe to Kainat Rana Worldview for more mind-blowing content about space, science, and the mysteries of our universe. Thanks for watching, and see you in the next episode.